NVIDIA's customers, Amazon, Microsoft, Google, Meta, are spending $40 billion in 2026 to replace NVIDIA, not to add capacity, to replace Trainium 2, Maia 100, TPU V7, MTIA V2, four first-party chips designed to do exactly what an NVIDIA GPU does, only owned by the company that runs them. The market reads this as a long-term threat to the most valuable hardware company in the world. The market is half right. NVIDIA's training business is secure through 2028. Inference is already gone. The split between those two workloads is the entire story of NVIDIA's gross margin for the next 4 years. This is episode 4 of the AI Money Flow. Before we get to who wins, we need to be clean about what's actually being built. There are two completely different workloads behind every dollar in the $725 billion 2026 CapEx. Training. One model, frontier scale, Llama 4, GPT-6, Claude 6, Gemini 3. Thousands of GPUs, weeks to months, custom communication patterns, novel mathematics every quarter. NVIDIA owns roughly 95% of training share. CUDA, NCCL, NVLink, 15 years of software moat that no other vendor has replicated at frontier scale. Inference, hundreds of millions of calls per day, single GPU or small cluster, mature workload, same operation millions of times. Per token cost is everything. NVIDIA still has roughly 60% of inference share, but trending down rapidly. The $40 billion of first-party CapEx is targeted almost entirely at the inference side. Amazon Trainium 2, built for cheap inference, named confusingly. Microsoft Maia 100, paired with Azure OpenAI. Google TPU V6 Ironwood, already running Gemini inference. Meta MTIA V2, running Llama internally. 4 chips, same goal, same target. NVIDIA's 70% gross margin on every inference token. Why hasn't this happened to training? 3 layers of moat. Layer 1, CUDA software stack, 15 years of compounding investment. Every PyTorch operator, every research paper's kernel, every Triton fused operation lands on CUDA first. The runtime ecosystem, QBLAS for linear algebra, CUDNN for deep learning primitives, NCCL for multi-GPU collectives, has no equal at frontier scale. Even AMD's ROEM, which has been catching up for years, still hits compilation edge cases on a meaningful fraction of frontier training runs. Layer 2, interconnect. NVLink at 900 gigabytes per second per GPU. NVS switch fabric scaling to thousands of GPUs in a single coherent training run. Training a frontier model means synchronized gradient updates across the entire cluster every few hundred milliseconds. The bandwidth and latency requirements rule out anything except NVIDIA's vertically integrated stack. PCIe-only ASICs are not in the same conversation. Layer 3, the talent and tooling network. Every PhD coming out of a top AI lab in 2026 writes CUDA. Every framework engineer optimizes for it. Every cloud customer deploys with it. The ecosystem effect is a flywheel that other vendors cannot break by spending more money. They have to wait for it to break itself. How long does this moat hold? The base case is 2028, when the Blackwell-Rubin transition is fully digested and Vera-Rubin starts shipping at scale. The bull case is 2030, when the next architectural shift might force a rewrite. The bear case for NVIDIA is 2027 if Google's JAX XLA stack proves it can host a frontier model training run end-to-end, which Gemini has arguably already done internally. Training mode is real, it just isn't permanent. Inference is the other side of the workload, and it is already gone, or on its way. The reason is structural. Inference is a mature operation. Same matrix multiply, same attention kernel, same KV cache read, executed billions of times per day. No frontier research paper kernel surprises. No multi-GPU gradient synchronization. No NCCL collectives. Just memory bandwidth and token throughput. That maturity opens the door to custom silicon. Every hyperscaler has now shipped a first-party inference chip. Amazon Trainium 2, confusingly named, but optimized for inference. 60% cheaper per inference dollar than equivalent NVIDIA capacity on AWS, used internally for Bedrock model serving. Roughly 15% of AWS inference traffic in 2026 is on Trainium. Microsoft Maia 100, explicitly paired with Azure OpenAI service. The economic argument, every GPT-5 token served on a Maia instead of an NVIDIA hopper saves Microsoft 60 cents per million tokens. At Microsoft's scale, that's billions per year. Google TPU v6 Ironwood, by far the most mature non-NVIDIA accelerator. Google has been training and serving Gemini exclusively on TPU since 2023. V6 Ironwood is the first model line that competes with B200 on raw performance per dollar. Meta MTIA V2, narrowest scope, but Meta runs Llama 4 inference for Instagram, Facebook, and WhatsApp recommendation systems on MTIA. The capex is small, but it pulls Meta out of NVIDIA's per-token tax permanently. The combined effect, NVIDIA's inference share dropped from roughly 90% in 2024 to roughly 60% in 2026. By 2028, the consensus estimate is 40%. NVIDIA still wins absolute revenue because the market is growing. The gross margin is the question. The four hyperscalers will spend roughly $40 billion on first-party silicon in 2026. That number is the part the market keeps misunderstanding. The breakdown. Amazon Trainium and Inference, around $15 billion. Google TPU, V6, Ironwood, and V7, $15 billion. Microsoft Maia, 100 plus Cobalt CPU, $5 billion. Meta MTIA V2, $5 billion. That capex looks small compared to the $725 billion total, but the math on it is dramatic. Every dollar an enterprise spends on an NVIDIA GPU instance through AWS, roughly 70 cents flows to NVIDIA's gross profit. NVIDIA gross margin on data center chips is currently 73%. The hyperscaler keeps the remaining 30 cents, and that's before paying TSMC, HBM, optical, and power. Every dollar an enterprise spends on a Trainium instance flows to AWS at, conservatively, 90% margin. AWS keeps 90 cents, pays roughly 10 cents for TSMC, HBM, and assembly. So for every dollar that migrates from NVIDIA to Trainium, AWS captures roughly 60 cents that previously left the company. At AWS's scale, projected $60 billion in AI inference revenue by 2028, even a 30% migration captures $18 billion per year of gross profit that NVIDIA would have earned. The $40 billion in first-party capex pays back in about 20 months on inference volume alone. The implied internal rate of return is north of 40%. There is no scenario where the hyperscalers stop building. NVIDIA can match prices to slow the migration. NVIDIA can keep adding training-side features that customers can't replicate. NVIDIA cannot stop the math. The reason inference fell first, and training is next, is that CUDA's moat is eroding from above, not below. Above is the model layer. PyTorch's torch. Compile abstracts CUDA. ONNX runtime abstracts CUDA. OpenVINO abstracts CUDA. JAX explicitly does not target CUDA. It targets XLA, which can compile to TPU, GPU, or CPU equally well. Every major model framework now treats CUDA as one of several backends. Below is the kernel layer. Triton, originally an NVIDIA-focused compiler, is now used by Meta, Google, and Anthropic to write kernels that run on multiple targets. Mojo, Modular's language, explicitly targets cross-vendor accelerator portability. The Vulkan-based MLIR pipeline is closing the gap on the last bastion of CUDA-specific code, custom training kernels. What this means in practice: a Llama 4 model trained on NVIDIA can be served on Trainium with low single-digit % performance regression. A GPT-5 inference workload deployed on Maia delivers 95% of what the same model gets on H100. 5 years ago, those numbers would have been 40%. Today, they're 95%. The implication: the CUDA moat is no longer about software. It's about institutional inertia. Every additional year that PyTorch and JAX broaden their backends, the cost of leaving CUDA falls. NVIDIA's response has been to make the moat sticky in a different direction. Blackwell NVLink Spectrum X creates a vertically integrated stack at scales other vendors can't match. That's the training moat. It works through 2028. Past that, the moat depends on whether NVIDIA's hardware advantage outpaces the framework portability advantage. The market is betting it does. The technical trend is betting it doesn't. So who wins? 3 layers. Definite winner 1, NVIDIA on training through 2028, 95% share, 73% gross margin, no serious competitor at frontier scale. This part of the business is worth $500 billion by itself. Definite winner 2, the hyperscalers, structurally and permanently. Every first-party chip they ship is gross profit retained from a third-party vendor. AWS, Microsoft, Google, and Meta have collectively pulled tens of billions in inference revenue out of NVIDIA's P&L and into their own. That doesn't reverse. Definite winner 3, the same upstream supply chain we covered in episodes 1 through 3. TSMC fabricates Trainium and Maia and TPU and MTIA. HBM ships into every accelerator regardless of brand. KLA inspects every wafer. The supply chain is paid in cash, in advance, regardless of which logo is on the package. Conditional winner, NVIDIA itself, conditional on training share. If NVIDIA holds training share through 2028, revenue keeps growing even as inference share migrates. Gross margin probably compresses from 73 to 60 in that window. Revenue grows by maybe 40%. The stock multiple takes the hit, not the absolute earnings. Losers, startup ASIC vendors without a captive customer. Cerebras, Grok, Samba Nova, Tenstorrent. The market for a generic ASIC that competes with NVIDIA on the open market is smaller than the market for a chip that has guaranteed deployment inside a single hyperscaler. The 4 big tech first-party programs leave very little oxygen for independence. Net of all this, NVIDIA is not dethroned. NVIDIA is re-rated. The training premium survives 2028. The inference tax is already migrating. The stock multiple priced for permanent monopoly is not the stock multiple that fits a slow conditional monopoly. Next episode in the AI money flow looks at the demand side and the awkward fact nobody at AWS or Microsoft or Google likes to talk about. 95% of enterprise generative AI pilots never ship to production. MIT studied it. Gartner confirms it. Every Fortune 500 CIO has a deck of dead AI projects. The $40 billion in first-party silicon, the $725 billion in hyperscaler capex, the $1 trillion inference rental market. All of that assumes enterprise demand at scale. The demand isn't there yet. What's actually blocking the deployment, why the pilot to production conversion rate is so low, and which categories of customer actually do ship. That's episode 5 of the AI money flow. If you want the actual industry view on where AI money flows, not the headline, not the narrative, the actual P&L, subscribe and stay with this playlist. 6 episodes. 1 question, who actually profits? This is VLSI Tech Explained.